This is going to be a trig sub problem. If you haven't watched the video on how to derive the triangles that you need for these problems without memorizing them, go ahead and do that because I'm going to be referencing these triangles throughout the video. And yeah, let's go ahead and get started. So you've already tried u sub, which was a strategy to make integrals easier to solve by putting everything in terms of u. So similarly, trig sub is where we just put everything in terms of theta. So the first thing is to find the triangle. How do you find the triangle? Well, trig sub problems are always going to have a square root and a coefficient a and x. And so in this case, I see this. It looks to me like this is more like an a squared minus x squared type of problem, where a is equal to 6. So right, 6 squared, that's going to give us 36. And so then you take this and you go to the back sheet of your exam, because this is where I put my triangles, and I look at which of one of my triangles contains that, and it's this one. This one contains the a squared minus x squared right here. So then I'm going to go ahead and take this triangle and put it over here on the side of my paper. Then after I get my triangle, my whole strategy is to put everything in terms of theta, right? So that includes this. I start with this. So the strategy here is to always put what you want at the top. It's going to be a squared minus x squared, and I don't use numbers. I just do a is equal to 6. Okay, so then I put a at the bottom always, and then I'm like, blank of theta is going to give me that. That's my question. What if theta is going to give me that? Is it going to be cosine, sine, or tangent, or something else? So what I do is I label my triangle. So this is opposite, this is always going to be hypotenuse, and this is adjacent. So then I label these. I'm like, okay, well then what's this? This is adjacent. So it's going to be A. And then what's this? Well, that's going to be hypotenuse. So then I ask myself, given SOHCAHTOA, which one is going to give me adjacent over hypotenuse? Cosine. So then now I know that cosine of theta is going to give me that. But remember, I want to put this in terms of theta. So I can literally just solve for that by multiplying both sides by A. So I'm going to do a cosine theta is equal to a squared minus x squared. And that, ladies and gentlemen, is your first little substitution. So now you can replace the denominator with a is 6, so 6 cosine of theta. Beautiful. The next thing you want to replace is the x squared. So in order to replace the x squared, I'm going to have to find x in terms of theta. So to find x in terms of theta, I guess here I should say this is find, I'm going to call this the main thing. To find x, you put what you want at the top. I want x. Put a at the bottom, and then you say blank of theta is going to give me x over a. Well, what's x? X is opposite. What's a? A is your hypotenuse. So which one's going to give me opposite over hypotenuse? Sine. So sine of theta is going to give me x over a. But I want x because that's what I want to replace. So I'm going to multiply both sides by a. Literally, this is why I put a at the bottom. It's so easy to get rid of it, right? So we're left with a sine of theta is equal to x. And there you go. That's another sub. Isn't that beautiful? So now you can replace this over here with 6 sine of theta. Keep in mind, a is equal to 6. I'm just plugging in 6. And do not forget that it is squared. Then we want to put dx in terms of theta. So to put dx in terms of theta, just remember that's really just x prime. So we take x, which is a sine of theta. X prime is just going to be a cosine of theta. So times d theta, because we took the derivative, and x prime, again, remember, is just dx. So this is another beautiful sub that we have here. So a is 6, remember that. So that's going to be 6 cosine of theta d theta. And now I have to also put my bounds in terms of theta, because right now they're in terms of x. X is equal to 0, x is equal to 6. I need those in terms of theta. So I need to actually find theta. So to find theta, I always take this formula with the x, and I say, okay, I want to solve for theta, so I can divide by a. So now I'm left with sine of theta is equal to x over a. And then to solve for theta, remember, it's just arc sine. It's the inverse. So arc sine of x over a is equal to theta. So if I have x is equal to, what do I have it, 0? And I have x is equal to 6, what is theta? So theta is going to be arc sine of 0 over 6, because a is 6, remember that. And then here, arc sine of 6 over 6. This is just 0, this is just 1. So for the first one, we're really just asking sine of what is going to give us 0. Remember that this is 0, this is pi over 2, this is 1, 0, this is 0, 1. Sine of what is going to give me 0? Well, sine of 0 is going to give me 0. And then sine of what is going to give me 1? Well, sine of pi over 2 is going to give me 1. So now, even my bounds are in terms of theta. So we have 0 and pi over 2. And so this is what I mean. All my sub work is going to be here. I substituted everything. I put everything in terms of theta. But all the work to find everything in terms of theta goes here. And then my scratch work goes over here. So now gets to the fun part. These things cancel out, thank God. So we're left with this times d theta. We can distribute the 2. We can move the 36 to the front. And we know a little nice trig identity or formula called the half angle formula, because I see that this power is even. We're going to do the half angle formula, which states that sine squared of theta is equivalent to 1 minus cosine of 2 theta over 2. Then I can take out this 1/2, and then I can easily integrate, so this just becomes theta. And so when we take the antiderivative of that, that just becomes sine of 2 theta, and kind of the inverse of chain rule, you would usually multiply with what's on the inside, but because we're taking antiderivative, we're going to divide by what's on the inside, and that's all being multiplied by 36 divided by 2, which is 18. And so that's all being evaluated from 0 to pi over 2. And so fundamental theorem of calculus, we plug in pi over 2, which is just sine of pi, and then minus 0 minus sine of 0 over 2. Now if you do the work, remember sine of 0 is just 0, so this cancels out to be 0. This whole thing is just 0. And so then sine of pi, well, pi, remember, is -1, 0. And so sine of pi is 0, so this cancels out to be 0, and we're left with 18 times pi over 2, which is 18 pi over 2, which is 9 pi.